Okay, so let's we'll talk about these new terms in a second. Let's go ahead and solve this inequality here. So we get negative 3x, subtract 10, less than 2x minus 10. I'm going to subtract 2x from both sides, negative 5x, less than negative 10. And you may remember this rule. When you divide by a negative, so not subtracting, but dividing by a negative with an inequality, the sign is going to flip directions. So this will now be greater than 2. So my graph here, I'm going to put an open circle at 2. So we talk about inclusive point or closed point. So the solutions x are bigger than 2. They're not equal to 2. So this is going to be an open point here. So an open point at 2. The x values are the solutions. They're larger than 2. So the graph looks something like that. And boundary point, this is called a boundary point, at least, fewer, at most. Those are some of the, so like at least is greater than or equal to, fewer is less than, at most is less than or equal to. You'll hear some of those terms. You'll need to translate those. And then there's something called interval notation. So interval notation is this. It has put a number, comma, another number. And what goes here is called the lower bound. Lower bound. And what goes here is called the upper bound. So lower bound would be 2 here, and at the highest it goes to infinity, so comma infinity. Infinity always has a parentheses on it. That means it's not included, it's not an inclusive point. And since this is an open circle, I'm also going to put a parentheses. If this was a closed circle, I would put a bracket there by the 2. So if this was a closed circle, I would have a bracket at the 2 there. So let's try to write this inequality. So we're working backwards here. I like doing that. So this would be an inequality notation. It would be x is, it looks like all the values are smaller than, so less than 3, negative 3. So this is inequality notation, and I could also write this using interval notation, which would be the lower bound is how it goes forever in that direction, so negative infinity. Infinity or negative infinity is always a parentheses, and the upper bound, it goes all the way up to negative 3. And that's going to be a parentheses because that's a non-inclusive point. The solutions are smaller than negative 3, not including negative 3. Solve a graph. So with this one, we're going to just go ahead and solve this real quickly. So we get, let's subtract 8a, so negative 8a, less than or equal to, subtract 72, so I get, or 73, I get negative 72. Divide by negative 8. Divide by negative 8. A is greater than or equal to, because I divide by negative at 9. So at 9, I have a closed circle, greater than has an arrow to the right. Like something like that. The final answer could be written this way, or in interval notation from 9 to infinity. It has a bracket at 9 because it includes that point at 9. Now we have compound inequalities. And so the first one we're going to do there is the AND statement here. So we have two compound inequalities. We're combining them with an AND there. You get negative 2x by subtracting 2x from both sides. Subtract 5, I get negative 6. Divide by negative 2, which means I have to switch the direction of the sign. X greater than 3. And divide by 2 here. I don't have to switch the direction of the sign in this case. X less than or equal to 6. So I like to, when I have a statement like this, I like to graph them up top. So here's what I mean by that. I'm going to graph this one up above, so not on the number line. My answer is going to go on the number line. So I'm going to say x is greater than 3. And I'm going to do this one in a different color here. This one is going to be x is less than or equal to 6. So closed circle at 6 and less than or equal to something like that. So the and statement, what this means is the intersection, the overlap of the two graphs. So green graph and the black graph here, they seem to overlap everywhere in between here. So I definitely have a point here at 3 and one at 6, and the graph is the overlap. But be careful, this one is a closed circle, so you're going to have to bring that down and say those two graphs overlap right there, where there's no overlap at 3 because the black graph does not include the point at 3. So your final answer, so this is your graph of your final answer, but let's actually write what the answer is. This would be something like positive 3, comma 6 bracket, because of the closed circle, open circle at 3. Or you could use inequality notation, something like this. Let's see, less than and less than or equal to. So we're saying that 3 is smaller than x, that's true. X, the solutions are smaller than 6 or equal to 6, and that's where that comes from. Try another one. So again, I like to kind of show my work up above. So x greater than 0 looks something like open circle at 0 and arrow to the right. And this one is open circle at -4, arrow to the left. Notice I have not combined these two ideas yet. So there is an and statement, conjunction here, that connects them. I want the overlap of those two graphs. So where's the green graph and the blue graph overlap? Is there any overlap there? There is no overlap. So my graph is empty. Don't really have a solution there, and my answer is the empty set. Let's change this question to be this. So x less than 0 and, sorry, just make it an or statement, or x is greater than -4. So if this is an or statement, I'm going to graph each one of these separately. So I've got x less than 0 looks something like this, open circle at 0. I've got x greater than -4, so greater than, open circle, arrow to the right. So it looks something like that. The or statement means anything that's a solution to one of them is a solution to both of them. So in this x greater than 4, any number bigger than -4, all these numbers are solutions. Lots and lots of numbers there. Anything smaller than 0 is also a solution. So all these numbers are solutions, right? So how do we represent all these numbers over here, which are solutions, all these numbers over here, which are solutions, not just the overlap? This is, if it's true for one, it's true. So I don't really see anything on the graph where there's not at least one of the graph is covering. So I think my graph would look like this. It would be like all reals. And I could say it this way, all reals or negative infinity, comma, infinity. Let's try an or statement now. So for an or statement, again, so let's start with graphing our thoughts. Up top, this is not my final graph. I'm just up above, so -2 is an open circle, arrow to the left, it looks like. The other graph is this one. Let's see, at 3, open circle and arrow to the right. So if I were to meld these, this is an or statement. There is no overlap of these two graphs, by the way. That would be the empty set. But since anything here is a solution, anything over here is a solution. There's lots of different solutions there. So my final graph is this. Both of those are solutions. I could rewrite it like that, or maybe say an interval notation, negative infinity, comma, -2, parentheses, union with 3, comma, infinity. And you've got it. That's the list.